Welcome, everyone. Thank you for being here today. I'm excited to introduce our presentation on pumps in the oil and gas industry. Today, we'll be exploring an overview of both dynamic and positive displacement pumps. Over the next few slides, we'll cover their types, functions, and importance in the industry. Let's get started. Today, I want to talk about the main types of pumps that are commonly used in various applications. First, we have the dynamic pumps, specifically centrifugal pumps. These are ideal for moving high volumes of fluids that are low in viscosity, like water, light crude oil, or gasoline. They work by converting rotational energy into fluid movement, making them very efficient for large flow rates. On the other hand, we have positive displacement pumps. These are suited for situations where high pressure is needed, especially with more viscous fluids like heavy crude or asphalt. Unlike dynamic pumps, positive displacement pumps trap a fixed amount of fluid and then force it through the system, which allows them to handle thicker, more resistant fluids effectively. Understanding these differences is crucial because selecting the right pump depends on the specific fluid properties and the required pressure and flow rates. This distinction helps us optimize performance and ensure safety in the pumping process, connecting directly to our broader discussion on efficient fluid handling. Let's take a closer look at the key components of a centrifugal pump. First, we have the impeller. This is a critical part because it converts the mechanical energy supplied by the motor into fluid velocity. Essentially, it's what gets the fluid moving at high speed. Next, we have the casing, also called the volute. Its job is to guide the flow efficiently, directing the high-velocity fluid from the impeller towards the discharge pipe while minimizing energy losses. Moving on, the shaft and bearings play a supporting role. They support the impeller and ensure smooth rotation, transmitting power from the motor to the impeller without wobbling or excessive wear. Proper support here is vital for the pump's reliability and longevity. Lastly, we have the mechanical seals. These are crucial because they prevent leaks where the shaft exits the pump casing, ensuring the fluid stays contained and the system remains sealed. All these components work together seamlessly, exemplifying how each part plays an essential role in the overall function of the pump. When understanding these components, it becomes clearer how a centrifugal pump efficiently moves fluids in various applications. Let's take a closer look at how pumps are used across the entire oil and gas chain. In the upstream phase, pumps play a crucial role in activities like drilling mud circulation, water injection for well maintenance, and artificial lift systems to enhance production. These applications are essential for ensuring the efficiency and safety of the initial extraction process. Moving to the midstream segment, pumps are vital for transporting crude oil and gas through pipelines, as well as supporting booster stations that help maintain pressure and flow over long distances. This stage is all about moving resources reliably and efficiently. Lastly, in the downstream sector, pumps are key in refining processes, blending operations, and petrochemical production. They help ensure that the final products meet quality standards and are ready for distribution. Overall, pumps are the backbone of the entire oil and gas supply chain, enabling seamless movement and processing at every stage. When it comes to selecting the right pump, it's all about matching the pump type to your specific application and fluid properties. For instance, if you're dealing with high-flow, low-viscosity fluids, a centrifugal pump is usually the best choice because it can handle large volumes efficiently. On the other hand, if you're working with high-pressure, thick or viscous fluids, a positive displacement pump is more suitable because it can generate the necessary pressure and handle those challenging fluids effectively. The key takeaway here is to always consider what you're pumping, its properties and the application's requirements, and choose a pump that aligns with those needs. This matching process ensures optimal performance, efficiency, and reliability in your system.